covering parts of L.A.M.E.C.O.W, MEC, starting out with mountain barriers, elevation, and ending with continental location. All of these factors affecting climate of an area. First of all, within mountain barriers, we do need to know that they are creating something called a rain shadow. Okay, we have to think about what is happening with the mountains themselves. The mountain barriers are blocking air patterns from moving in their normal way. Okay, the mountain stands firm and the air then has to move around it. So by the phenomenon of the air being pushed up and around the mountain, we call that the rain shadow effect. Now this rain shadow, what it does is typically creates a desert type of a climate. And so we end up seeing on one side of the mountain, like the Sierra Nevadas, one side in California we have a lot of precipitation and a lot of vegetation, while the other side, for example in Las Vegas, within the rain shadow, ends up with a complete desert environment. So on one side of the mountain, we see a much different climate and ground cover than we do on the other. And I'll show you the example here. Here is where our Sierra Nevada mountains are, right along the border of California and Nevada. Now we can see over here on this side, we end up with a lot of green. Okay, in order to get a lot of that green, of course, we're going to have a lot of precipitation or rain. On this side of the mountain, we can see there's quite a different cover. It's a lot drier, a lot less rain, making for our desert climate. Okay, so simply the fact that these mountains stand here, something is happening with the air coming in, causing it to dump the rain on this side, leaving the air dry to make a desert on the other side. So what we have to think about is this. As the air approaches the mountain, again, it can't go through. It's got to go somewhere, and the only place for the air to go is up. As that air is pushed upwards, what type of pressure system is it going to make? We have this air rising up. Air that rises up is going to be low pressure. And of course, what is always connected to low pressure systems? Clouds and rain. As this air is brought towards the mountain and forced upward in a low pressure pattern, the rain comes out. Okay, we can see up here in this image, I've got my nice thundercloud with the rain happening. What is that rain going to help produce? Trees, plants, vegetation. All of this rain supplies this entire landscape with all the rivers to feed those plants. Now as that air reaches the top of the mountain, it is completely emptied out. It's like a washcloth being wrung out. There is no more moisture remaining in this air, and as it comes down the other side of the mountain, what type of pressure system do I have now? Sinking air, high pressure. What kind of environment do I get with high pressure? High and dry. Check out my climate up here. I have dry air, dry landscape, lacking vegetation because all the water was dumped out on this side. So again, this whole rain shadow effect occurs because of the mountain barrier. The air is brought towards the mountain, can't go anywhere but up. As it moves up, low pressure is created, making clouds and rain on the one side, creating vegetation. As that air approaches the top of the mountain and crosses over, it has to sink back down to normal elevation, creating high pressure, which is my dry landscape, high and dry. That is my desert on the other side. Okay? Now you have an image similar to this on your packet. We want to label a couple things. Okay? With your pen, we definitely want to show the direction of the wind, and that is shown here in the diagram, but you can go ahead and add your own. The side where the wind comes from, we give that the name Windward. Okay, the windward side is the side of the mountain where the wind is approaching. So because the wind is moving in this direction, we call this the windward side. Now again, as the air approaches, it can go nowhere but up. As it goes up, low pressure is made, and as we can see in our picture here too, the rain is created. Now I would recommend adding yourself a little tree on here, so you know this is your vegetation or some grasslands. Right? This is where the plants grow because the rain is forced out of the low pressure system as the air is pushed up and over the mountain. Now as that air reaches the top and carries over to the other side, it is forced downward, making a high pressure system. You have it labeled there as dry air. I would go ahead and draw yourself a little cactus there, reminding you this is your desert climate. We call this side of the mountain the leeward side. Okay, so we have two key terms to remember here in terms of the mountain barriers. We had windward, the side where the wind is approaching, and we have the leeward side, or the dry side, where the high pressure is sinking back down the other side of the mountain. Okay, so a couple things labeled on the diagram there. Now here is a real-life island in the Pacific Ocean, which we can kind of see where the mountain barrier would be taking place. We clearly see one half of the island as green, the other half of the island as the desert. So I know my mountains have to run right along this chain. Now the question is, where does the wind have to be coming from? Which one is going to be my windward side? Looking back at our diagram here, the windward side is the side with the rain where the wind approaches, and that low pressure forcing the air up causes the rain to come down, making the vegetation. So my vegetation side would be the windward side, the side where the wind is coming from. So clearly, by all the greens happening over here, this has to be my side with the trees. The wind has to come from this direction, becoming empty as it moves over to the other side of the mountain, giving me my dry desert climate on the far side. So really, the windward leeward can be on either the left or the right, just has to be wherever the wind is coming from. And that's the windward side. So thinking about it, what side of the mountain would be near an ocean, receiving the least amount of rain? Okay, what would I call that side, the side with the least amount of rain? Again, the mountain forces the air upward. Forcing up of the air creates the rain. That is my windward side. As the air approaches the other and sinks, that is my leeward side. So the side of the mountain with the least amount of rain, I would call that the leeward side. Okay? So typically the climate that I see on the windward side would be cool and wet. Again, that's the side where the rain comes down. And the leeward side would be my warm and dry. As that air sinks back down, it is completely empty. I've got high pressure system working on this side, high and dry, creating no rain or the rain shadow on the leeward side. Okay, moving right along to the E. E is for elevation. Remember, another word for elevation is altitude. So thinking about how high above sea level are we for elevation? Okay, you already know a little bit about temperature and elevation, so just to get you thinking about it, I have two cities here, Quito, Ecuador, and Guayaquil, Ecuador, both labeled on this map, Quito and Guayaquil. You have a key down in the bottom right corner telling you that the darker colors are higher up in the mountains and the lighter colors are lower in valleys. What do I know about the climate in this case, or what would you predict the temperature of each of those cities to be based on their elevation? Here I see Quito in the dark colors telling me it's higher elevation up in the mountains. Here I see Guayaquil down at the river valley. What would I know about its temperature related to elevation? Here are their current temperatures for the last calendar year. We can see Quito has a pretty solid and steady average. We're going to roll that one up right about 58 degrees. And in terms of Guayaquil, overall they have a few higher temperatures throughout the year, giving them an average of 79 degrees. Quito, again, was higher in elevation, close to the mountaintop, where Guayaquil was down lower in the river valley. What is our connection here between elevation and temperature? We know that as elevation increases, temperature decreases, right? The higher I am up the mountaintop, the cooler the air becomes. And that's traditionally why we tend to see snow on the top of mountains. The temperature there is cooler. Now, typically, for every about 1,000 feet that we go up a mountain, the temperature drops right around 3 degrees. Okay, so 3 degrees Fahrenheit is lost every 1,000 feet that you go up. Now, we typically tend to see in a highlands type of climate, in mountains, we typically see the lower elevations with the vegetation. Okay, so we can see here in this image, the very tip tops of the mountains are fairly bare and rocky, where the lower elevations have all this beautiful green. Okay, again on this picture, the higher up we go, we are increasing 3 degrees every 1,000 feet. Now this map doesn't go every 1,000 feet, it goes up 3,000, so we got 9, 10, 11, it goes up 4,000 feet. So we see that change within all the degrees. But the higher we go, the cooler it gets. And we tend to see that vegetation happening here lower on the mountain. Again, we can bring into the fact what we talked about with the rain shadow. As that air approaches the mountain, it is forced upward, making low pressure, causing the rain to happen here, giving the water that is needed to the vegetation. The higher up we go, the cooler those temps are. I'm running out of water, and my plants are no longer able to bloom there. Okay? So what we need to know for elevation, the higher we get, the cooler the temps. 3 degrees every 1,000 feet. Again, this is something you know, just a simple science explanation. Our final L.A.M.E.C.O.W for today is continental location. C, continental location. How does our location on a continent clue us into the climate when the elevation and the latitude are the same? So here I have 2 cities with the same latitude. Okay, their elevation is the same. One is not higher than the other. How would these climates differ? The main difference between these two then is their continental location. Here I have a coastal city, where here I have an inland city. That simple fact causes a change in climate. So continental location is really stating where is it on the continent. Is it the coast or is it inland? Now, large bodies of water, like oceans, are slower to heat and cool than land. Are slower to heat and cool than land. As a result, water temperatures tend to stay stable because they don't heat and cool as much throughout the day or throughout a season, whereas land temperatures change pretty frequently. And we talked about this earlier in our unit when we talked about which heats up faster, the sand or the water. In your bare feet, you'd rather stand in the water because the sand during the day gets really hot. But we also know the sand at night cools way down. The temperature change with land is very extreme. I get extreme highs and extreme lows, whereas the water stays much more stable. It does not heat up as much or lose as much energy at night, so areas near the coast or coastline cities tend to have stable temperatures, where cities that are inside the continent, like Minnesota, tend to have extreme temperatures. We get really hot during the day and cool at night. Or even within our seasons, we get very hot during the summer and very cold during the winter due to the rapid heating and cooling of the land. A city near the coastline, like a San Diego, isn't going to heat up as much or lose as much heat at night because the water is there to balance its temperatures. Okay? So really what water does is it moderates the air temperature. Okay? It keeps the summers cooler and the winters warmer, simply by being closer to the land. I see a much smaller range within coastal cities than I do within inland cities. So looking at some data, which city would I hypothesize would be closer to a large body of water? Here I have City A, where I see the temperatures in December and January are very cold, under 0. They get very warm, up to 25, and this is Celsius. Okay, 25 degrees Celsius during the summer, and then get back down during the months of December. My second city, City B, starts out right around 9 degrees Celsius, will increase in the middle of summer to right around 13, and then get back to 9 during the winter. Which one is likely to be closer to a large body of water? If we think back to our discussion, talking about water heats and cools much slower than land, water is going to moderate the temperature, giving the summer a little bit cooler temps and the winter a little bit warmer temps. Knowing that the water moderates the temperature, that definitely tells me B is going to be closer to the water. I know that because I have a smaller range in temperatures, or a smaller change, right? I don't get the big increase or decrease here like I do in City A. This one is clearly the inland city, getting very hot in the summers, very cold in the winters. One more look at data. We have 2 cities in Texas, and we want to figure out which one is likely the coastal city, which one is likely the inland city. So we want to calculate the range of temperatures for each month. We have 2 months to look at. Here we have one city of Donna. Its high during December is 69, and its low is 48, making its range 21. 21 degree difference within December. As far as South Padre Island goes, its range is 15 degrees. Okay, so Donna has a change of 21 degrees within December. South Padre Island has a 15 degree range in December. Looking at the August information, we have our December data still posted here. Looking at the August information, Donna's range, if I subtract these from each other, the range here would be 22 degrees, and South Padre Island would be 12. Again, thinking about their locations based on the range in temperatures, I know that any city by the coast is going to have a smaller range in temperatures, where any city inland is then going to have a larger range in temperatures. So looking back at the data here, I've got Donna posting a range of 21 and 22, a much larger range than South Padre Island at 12 and 15. That clues me in that with that small range in data, South Padre Island must be my coastal city. South Padre Island is right around in this neck of the woods for Texas, where Donna is right in the middle of the peninsula here, becoming my inland city. Being inland, it has a much larger range in temperatures, seeing that 20 plus degree difference within the month, where South Padre Island was more in the teens, 12 and 15. Okay, so the M and the E and the C all finished for L.A.M.E.C.O.W. We have a few summary questions to complete, practice questions to make sure we fully comprehend what's going on with mountain barriers, elevation, and continental location.